So here's another question, A-level physics question from the thermal physics topic. If you want to answer the question yourself, pause the video now. If you've got the answer C, well done. So, two flasks, X and Y, are filled with an ideal gas that are connected by a tube of negligible volume. Let's draw what we've got here. We've got our two flasks. One's imaginatively called X, and the other is called Y. The volume of X is twice the volume of Y. X is held at a temperature of 150 Kelvin and Y is held at a temperature of 300 Kelvin. What is the ratio of the mass of gas in X and the mass of gas in Y? Okay, so one thing I can say immediately, well, we're told the temperature, so I can say what the temperature is, but I can also say the pressure in X and Y is the same because they're connected together. So what equation am I going to find in my data sheet to help me answer this question? And I'm going to look at this one here, that the pressure multiplied by the volume of gas is equal to the number of moles multiplied by the molar gas constant multiplied by the temperature. If I rearrange that, I can get pressure multiplied by volume over number of moles multiplied by temperature equals that molar gas constant. So what that's saying is, if I change the pressure, then the volume or the temperature or the number of moles will change, but it'll still give me that constant R. So I can say the gas in X is going to have the same value of R compared to the gas in Y. So I can then say that the pressure in X multiplied by the volume in X over the number of moles of X multiplied by the temperature of X equals R, which also equals the pressure in Y, the volume in Y, the number of moles in Y, and the temperature in Y. So we're trying to find the mass of the gas in X and the mass of the gas in Y. Well, the mass is going to be directly proportional to the number of moles. So if I find the ratio of the number of moles, I'm going to find the ratio of the masses. So let's rearrange this equation now, and I can say the number of molecules of X, moles of X over the number of moles of Y is going to be equal to the pressure in X over the pressure in Y multiplied by the volume of X over the volume in Y multiplied by the temperature in Y over the temperature in X. So let's put some numbers in here. Well, I said the pressures were the same, so those ratio of pressures is going to be 1 and 1. The volume of X, what were we told? We were told it's twice, the volume of X is twice the volume of Y. So I can just say that's 2 over 1 for the volumes. And the temperatures, X is at a temperature of 150 and Y is twice as hot at 300 Kelvin. So again, I can just put it in as ratios. So altogether, that comes out as 4. So the ratio of the number of moles of X over the number of moles of Y is 4, but that's going to be exactly the same as the mass of X over the mass of Y. Okay, so the answer was C. If that was useful, subscribe, like and share, and watch more of them in the series, please. Thank you for watching.